Do it. All right. So we are on week 5. Two things to do this week, both on transformations. We're doing translations and reflections today. Then on Friday, you guys will have dilations and rotations. Um, so there's a notes page, looks like this, has your videos, and it also has these 2 links. So these 2 links take you to some pages, and so I wanted to show you some of these tools. I'll show you the simple one. If you like them, you can look at the more advanced one. So the first thing we're doing is rotations. So if we were in person, I really think this works better um, on paper where you can just rotate it, but this is the next best thing. So this is translations. This is the easiest one that we're doing. So what we're gonna do, we're gonna translate this triangle. We're gonna move it in the X direction. So here's how that works. Oops. Okay, now we're gonna do a square. So you take each point and you move it up in the Y direction, sorry. So you take each point and you move it up, and then you just slide that whole figure up like this. So this is a great tool. Let's go this way this time. If you like it, you can do the one that has more customizable shapes, but this is what we're doing. These are translations. So you move each point that far that direction, and then you just slide the whole figure over. I think somebody is here. So that's translations. That's what we're looking at when we're doing that, the work for those. We're also looking at reflections today. So when you have a reflection over a line, so this would be a reflection over, let's say, the y-axis. It'll look like this. You'll notice at this middle point here, the distance to the left triangle and the distance to the right triangle, they're the same for each point. For each corresponding point, the distances are the same. Even if we pick a different shape. Let's do a horizontal reflection this time. So this is what that looks like. You know what reflections look like. So it's this isn't like anything super complex. And then you have diagonal reflections also. That one's not pretty. So yeah, you get the idea that you reflect them across the line. Let's go into some examples. So there's 2 types of transformations you're doing today. Oh, also, this is important. Give me a sec. Okay, so for translations, what are we doing? We're doing translations and we're doing reflections. So I'm going to show you where that is on the formula sheet. I don't have that tab open. So let's go back to our geometry class. And then at the top, you have all the formulas. So right here, formulas. So what I'm going to be looking at today is reflections, and where is the other one? Oh, okay, no, they're right here. So reflections. This is really the only one we need to use today. Reflections. I'm actually going to screenshot this in my computer so I can look at it later. I'm doing examples. Perfect. So just to show you what I have going on, if you look at my screen, I have that, the formulas right there, so I can see them while I'm doing these examples. So that is a useful thing for you to have with you while you're doing these. But for translations, we actually don't need them because it's pretty straightforward. So these are 3 different ways to write the same type of transformation. So yeah, you have your original point here is 5, 7. So this means you add 4 to the x. This means you subtract 3 from the y. So 5 plus 4 is 9. And then 7 minus 3 is 4. That's the answer to this one. Same thing here, right? Your original xy is 5 and 7. So really what you're looking at here is 5. Oops, no, didn't mean to write that. 5 plus 4, and then the y is 7 minus 3. So it's going to be, the answer is going to be 9, 4. This works best with the graph. So I'm just going to make a rough graph over here. So 5 and 7. So let's say 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So 5, 2, 4, 6, 5, 7 would be here, approximately. Then you go 4 units right. So here's what's happening. 1, 2, 3, 4. And then 3 units down. 1, 2, 3. So about here is where that would be. So that's 9. And then this is 4 here. So that's what's happening there. Did we get the same answer? Yeah. Same answer even with a bad drawing. So imagine how easy that would be if you had a good drawing or a real graph that you could do that with. So that's translations. The reflections, so now I'm using these formulas that I have here on the screen. So here's the point. This is going to be A and B. So reflection over the x-axis. Reflecting over the x-axis, I'm just going to write all this down. You do A, and then you switch the sign for B. Reflection over the y-axis, you switch the sign for A, and then you keep B. For y equals x, you flip both of them and keep the signs the same. And then for y equals negative x, you switch both signs and you flip both of them. Okay, so your answers. Reflect over the x-axis. -2 stays the same. You change the sign of this one. You change the sign of -2, so that's actually +2 and 3. But you would write that as 2, 3. Don't enter that in the answer box. For this one, you flip them. So B goes first, A stays the same. And then the last one, you change both signs and you flip them. So +3 becomes -3, -2 becomes +2. Okay, that is how this works. So that is translations and what's this one called? Reflections. So let's do some rough graphs here also, so you have something to look at on this page at least. Okay, so we started off on each one. It was -2 and 3. So about here is where these started off. So I'm gonna put all those in there. A reflection over the, so it goes x, y equals x. Okay, so reflection is here, reflection here, reflection here, and then reflection here. That's what we're looking at. So what you ended up with was this one ended up here, this one ended up here, this one ended up here, and then this one ended up here. Can I verify that? So -2, -3, yes. 2, 3, yes. 3, -2, yes. -3, +2. Yeah. So these pictures correspond to these here. And that is that.